So with this problem set, what we're trying to do is first factor the trigonometric function and then solve for the possible angles that x could be between 0 and 360 degrees. Alright, so again, like I said, the first step is the factor. So here we look at both parts and we see both have cosine x. So what I'm going to do is pull cosine x out front, and then what I'm left with is 2 sine x. And when I take a cosine x out of cosine x, it doesn't just disappear. Remember, I'm left with a 1. So minus 1. And once you're here, you're just going to set both parts of the equation equal to 0. So cosine x equals 0, and 2 sine x minus 1 equals 0. So now I need to think, okay, what angles, based on my chart, or really on the unit circle, will give me a cosine of 0? And the two answers to that are 90 degrees and 270 degrees. And then, again, this part is a little bit of memorization. Also, you could use your chart or your triangles, whatever really method works for you. In the second, here we end up with sine x. 2 sine x equals 1. Sine x equals 1/2. So now I need to think, okay, what angle gives me a sine of 1/2? And I can pretty quickly know that that's 30 degrees. But I also need to know where else. So let's think if we have all students take calculus. ASTC. So sine is positive in the first and second quadrant. So I know 30 degrees in the first quadrant. But I also need to know 30 degrees in the second quadrant. So if this is 30 degrees, this is 180. This angle here must be 150. So you see I end up with 4 answers: 90, 270, 30, and 150. And this is going to be common for these types of problems to have 3 or 4 different solutions. For this next one, you see it's set up very similarly. Here we have a tan x and a tan x. So I'm going to factor out tangent x, and I'm left with root 2 cosine x. Again, when I take tangent from tangent, I have to make sure I put a 1 there as a placeholder. So I'll set both parts of the equation equal to 0. Tan x equals 0, I know that's when x equals 0 and 180. And now I need to solve this second part here. So I get root 2 cosine x equals 1. Cosine x equals 1 over the square root of 2. Looking at that, I don't have anything on my chart that is 1 over the square root of 2. But if I rationalize this, then I get root 2 over 2. And I know that cosine equals root 2 over 2 at 45 degrees. But then I need to find where else cosine's positive, which is in the fourth quadrant. So I'm looking at a 45-degree reference angle here. If this is 360, I can just do 360 minus 45, and I get 315 degrees. So those are my 4 answers for that problem. Number 3 is a little different. Now, careful here. I know a lot of people's first thought is to divide by tangent x, but we cannot do that. And you get sine squared x equals 1. But if we do that, what's going to happen is you're going to lose solutions. So that is not something you can do. So what we want to do is subtract by tangent x. So you get tan x sine squared x minus tangent x equals 0. And then you're going to solve this the same way we solved the previous 2 problems. So you factor out a tangent x. You're left with sine squared x minus 1 equals 0. Set both separately equal to 0. So you'd get x equals 0 and 180 again. Here, if I set this equal to 0, I add 1, so I get sine squared x equals 1. Remember, this is like saying that sine of x, the whole thing, squared, equals 1. So I want to take the square root, and I'd get sine x equals plus or minus 1, which I know occurs at 90 degrees and 270 degrees. Alright, so really you need to have these angles memorized, whether you memorize it from the chart or from the unit circle, whatever method works for you. You need to know them, otherwise this is going to be very difficult for you on top of the already new content where we're factoring these trig functions. This is another example of one where we have to subtract sine x. We can't divide. So sine x tan squared x minus, minus sine x equals 0. Factor out my sine x. tan squared x minus 1 equals 0. And once again, set both parts equal to 0. You can see it's starting to get a little repetitive. So sine x equals 0 at 0 degrees and 180 degrees. And tan squared x, so again I want a square root. So tan x equals plus or minus 1. And tangent, remember, equals 1 at 45 degrees. So it's going to be every reference angle in every quadrant, since it's plus or minus, with a reference angle of 45. So that's going to be 45, 135, 225, and 315. So there you see, because we got that plus or minus for tangent, we ended up with 6 solutions. So that's really the thing that's different about this. Here, this one's not all that bad. Remember, when we see tan squared x, that's the same thing as tangent of x squared. So I take my square root. So you get the tangent of x equals plus or minus the square root of 3. And again, if it's plus or minus, I need to look in all 4 quadrants, because tangent could be positive or negative. So I know if I look at my chart, tangent equals root 3 at 60 degrees. So now I need to look at a 60-degree reference angle in all 4 quadrants. Okay? So it's going to be 60 degrees, 120 degrees, 240, and 300. So when you get the plus or minus, you're gonna have a solution in all 4 quadrants. Number 6. This is here first. Remember, we want to isolate our whatever's being squared, so divide by 2. So sine squared x equals 1/2. Take the square root. So you get sine x equals plus or minus the square root of 1 over 2. Now again here, it doesn't look like I'm going to have a solution because I don't know the square root of 1/2. That's not one of my basic trig identities. But remember, you can change this to plus or minus the square root of 1 over the square root of 2. We know the square root of 1 is just 1. So plus or minus 1 over root 2. And this looks very similar to what we had in the first problem. So if we rationalize, you end up with sine x equals plus or minus root 2 over 2, which we know occurs when x equals 45 degrees. And again, so since it's plus or minus, I have to do 45 degrees in all 4 quadrants. So 45, 135, 225, and 315. Alright, so whenever you have that plus or minus, you got to look in all 4 quadrants. Alright, now we get into the ones where we have to factor. Okay, so the factoring portion should be a bit of a review. All that's new is the solving. I know this here is a perfect square trinomial. Okay, I could do the ACB method and solve, but since I know it's a perfect square trinomial, I know it's just going to be 2 cosine x minus 1 squared equals 0. And once you have that, all you're doing again is solving. So take the square root, 2 cosine x minus 1 equals 0, add 1, 2 cosine x equals 1, divide by 2. So now I want to know where cosine x is going to equal positive 1/2. So that's going to be in quadrants 1 and 4. Cosine x equals 1/2 at 60 degrees. So I know it's going to be 60 degrees, and 300 degrees would be a 60-degree reference angle in quadrant 4. So those are my 2 solutions there. For number 8, this one's I don't believe it's a perfect square trinomial because 2 is not a perfect square. So what you're going to want to do for this, you could either substitute in x for sine of x and solve it that way. So you could say 2x squared plus 3x plus 1, or you could just solve it right from here using the ACB method. Either way, as long as you remember to substitute back. So 2 and 3, so I know my 2 values are going to be 2 and 1. So 2, I'll continue going with the substituted way. So 2x squared plus 2x plus x plus 1 equals 0. So I'm going to do factor by grouping. Factor out a 2x, so I have x plus 1. Factor out a positive 1. So I'm left with 2x plus 1 and x plus 1 equals 0. I have to remember to substitute back in, so I have to substitute sine x back in for x. So I have 2 sine x plus 1 and sine x plus 1 equals 0. And again, I'm going to set each of these separately equal to 0. So 2 sine x plus 1 equals 0, and sine x plus 1 equals 0. So I'm going to subtract 1, divide by 2, and I'd get sine x equals negative 1/2. And here I'm going to subtract 1, so I'd get sine x equals negative 1. So here notice the sign is negative. So when I'm looking at my table, sine is negative in the third and fourth quadrant. So I need to find the angle in the third and fourth quadrant that equals 1/2. So the sine of 1/2 is 30 degrees. So what I want is a 30-degree reference angle in both the third and fourth quadrants. So 180 plus 30 is going to be 210. And 360 minus 30 is 330. And then sine x equals negative 1. I know that's at 270. Again, I have that memorized. You need to figure out a way to remember it. I just memorized the chart. That's the easiest way for me. Alright, here we have an instance where we can factor out a sine, right? Both of these have a sine in them. So I get sine theta minus 2 equals 0. So sine theta equals 0, and sine theta equals 2. Sine theta is never going to equal 2 because remember the graph of sine oscillates between 0 and 1. I'm sorry, negative 1 and 1. So it's never going to equal 2, so that's not going to have any solution. So now I'm just looking at this. So you get theta equals 0 and 180 because you're just looking at when sine equals 0. Alright, last one here. This is one where notice we have two separate trig identities, trig functions. So I'm going to want to use my identity to change cosine squared into sine squared. So I get 3 sine t equals 2 times 1 minus sine squared t. So I'm going to want to distribute. Then I'll add sine squared t and subtract 2. So 2 sine squared t plus 3 sine t minus 2 equals 0. And once I'm here again, I'm just doing the ACB method. So ACB, AC is going to be negative 4, B is 3. So it looks like my two values are going to be 4 and negative 1. So 2 sine squared t plus 4 sine t minus sine t minus 2. I'll group these. Now this is an example of leaving the signs in there. So you see it gets a little bit messier, but either way you're going to end up with the same answer. So I can factor out a 2 sine t, and I'm left with sine t plus 2. Factor out a negative 1, sine t plus 2 equals 0. So again, all I did was factor by grouping, so I got to finish that up. So I'll set each of these separately equal to 0. If I take this one, add 1, divide by 2, I get sine t equals 1/2. And as we said before, you're just looking for a reference angle of 30 degrees, so in the first and second quadrant, so 30 and 150, and that's because it's positive. And then here I'm going to get sine t equals negative 2 if I set it equal to 0. And again, we oscillate between negative 1 and 1, so that will never give us a solution. So our only answers are 30 and 150. So I know I went a little fast through this, but you can go back and look at problems that you need help on. Hopefully this will help you finish up the homework. Please come to class with questions tomorrow. Good luck with your work.